we're to our final assignment of this chapter and of this online course. So yay! Okay, so it's a review assignment combining log sines and log cosines. So there's going to be a little bit of each. So the hard part here is deciding what you're going to use. You're going to use the log sines, you're going to use the log cosines, you might even use Pythagorean theorem, might even just use trigonometry. So let's look at this first one. Okay, first thing to notice is we have side angle side here. So that's our first clue that and since we are looking for the area, we are going to use the sine area. So it's 1/2 of the two sides multiplied together times the sine of the angle, because it's side angle side. So you grab a calculator and you go 0.5 times 28 times 24 times the sine of 83, and your answer is 333.49. Number 2, now we're solving the triangle, and we notice that it's angle, angle, side. So we can use the law of sines, and I'm going to start out by finding the angle. So 180 minus 73 minus 42, and then that's going to be, put that in your calculator, and you get 65. Okay, so now I'm going to find side A. Sine of 73 over 34, so I'm doing the C's, equals sine of 42 over A. So A is 34 times the sine of 42. Find the answer there, and then divide that by the sine of 73. And you get 23.78, which rounds to 23.8 when you round to the nearest tenth. Next one, sine of 73 over 34, same ratio as before. This time I'm trying to find side B, so use angle B that we found earlier, that was 65. 34 times the sine of 65 divided by sine of 73 equals 32.2 when you round it to the nearest tenth. Number 3, we are again solving the triangle. And we have angle, side, angle. The first thing I would do is to find the angle degree, which is 90 degrees. So that is 90 right there. You could go ahead and use trig to solve the rest of it, but since we're in the law of sine modes, I'd probably just keep going. Sine of 24 over A equals sine of 90 over 43. Find the answer for A there, and the answer is 17.5. Then I'm going to use the Pythagorean theorem. 17.5 squared plus b squared equals 43 squared. 43 squared minus 17.5 squared equals b squared. Take the square root of that, you get 39.3 when you take the square root of that. That is number 3. Number 4, we are again solving the equation. And we know angle C is 26. We also know side C is 5. So I'm going to start out with that relationship. So sine, but I don't know A or B. So I've got to do 180 minus 26. I do know that this is an isosceles triangle. So if C is 26, then B is also 26. So I have sine of 128 over A equals sine of 26 over 5. Solve that for, solve that for A, and we get 5 times the sine of 128 divided by the sine of 26. So I get 8.98, so that's 9.0 for A. So A is 9.0, so I know it's going to be either that one or that one. Let's go ahead and find A, 180 minus 26, and minus 26 is 128, so A is going to be 128. So, and we also already found that B was 26, so that is our answer. Number 5, so let's look for the error here. So on this one we have a side, and an angle. So the law of sines can be used. So we would have sine c over 6. Well, there's the problem. C would be over 5, and sine of 55 would be over 6. So we identified the problem. That should be a 5. That should be a 6. And the length of the sides in the denominator should be switched. We're going to correct the error and find the answer. So we take 5 times sine of 55 divided by 6. Take the inverse sine of the answer, and we get 43.04. So roughly 43.0 for the angle C. Number 6. So tell whether you would use the law of sines or the Pythagorean theorem. Well, I noticed that B is 90 degrees, so we can use the Pythagorean theorem. This one, it really helped to draw the picture, because B is the right angle, then B is the hypotenuse. So that should be B. And then we can use Pythagorean theorem to find B. And B would be 16.2. Now, you could use law of sines, but I thought it'd be kind of fun to just use a trig identity here. So tangent of A is equal to 15 over 6. So if you remember how to find A, you take 15, divide it by 6, and then do the inverse tangent of that answer, and you get 68.19, so 68.2 if you round it to the nearest tenth. And then to find the other one, you take 180 minus 90 minus 68.2, and you get 21.8. Number 7. This one, the hardest part for me was just to, have my picture fit with the information. So Empire State Building is 0.6 miles from the Chrysler Building. It's a 145-degree angle when you look between the Chrysler Building and the Statue of Liberty. I think that's kind of cool. If you've ever been to New York, you should totally try this out and see if this works. So what we're trying to find is the distance between the Empire State Building and the Statue of Liberty, which is, going to be hard to measure because it includes a river. So this is a good way to do it. So we have sine of 145 over 5.6 equals the sine of the Statue of Liberty angle over 0.6. And, because what we're looking for here, we have to find the angle up here. So the first thing that I did is I found the angle of the Statue of Liberty. So 0.6 times the sine of 145 divided by 5.6. And then take the inverse sine of the answer, and you get 3.5. And now we can find the angle of the Chrysler Building. So 180 minus 145 minus 3.5 is 31.5. So now we're going to look for the sine of 31.5 over d equals the sine of 145 over 5.6, and solve that with our calculator. 5.6 times the sine of 31.5, divide that by the sine of 145, and our answer is 5.1013, so about 5.1 miles. Can you use the law of sines to solve this triangle? Well, law of sines, if you think about this, the sine of C over, no, that's not there. So I don't know this angle, I do know that side. I don't know this angle, I don't know that side. So none of the ratios that I need are complete. So no, can't use the law of sines. We'd have to use law of cosines. And if you remember, SAS is one of the things that we use law of cosines for. Number 9, solving the equation again. So SAS, I'm going to have to use the law of cosines. So if I solve for b first, I get b squared equals this big long thing. And the cool thing is you can just plug that into your calculator and you find that the answer is 30.0 when you round it to the nearest tenth. So that means that sine of a over 20 is equal to sine of 138 over 30. And then, so the sine of a, when you solve that equation, you get a equals 26.5. So 180 minus 138 minus 26.5 is 15.5 for angle C. Number 10, solve the equation. Again, we just know the three sides. So we're going to have to use law of cosines first. I chose to find a first. So 12 squared plus 5 squared plus 13 squared minus 2 times 5 times 13 times the cosine of a. When you solve that for a, you get 67.4. So now we can use the ratio sine of 67.4 over 12, and now solve for b, sine of b over 5, and we do that and we find that sine is 22, or b is 22.6. And the final thing to find the angle C, 180 minus 67.4 minus 22.6 is 90 degrees. So that's angle C. In looking this over, I should have realized that because 5, 12, 13 is one of those famous Pythagorean triples. We could have saved ourselves a little bit of work, but that's okay. It was some good practice with law of cosines, law of sines, and the triangle theorem. Last one, find the area of triangle ABC. And there is a problem similar to this on the quiz, so you'll want to know how to do it. First thing you need to do is find the semi, or the half area. So 1/2 times the sides all added together equals 33.5. Then you take 33.5 times 33.5 minus each of the three sides. And when you do that, oh, be sure you take the square root. So a classic mistake is just to multiply that all together. Then you take the square root of the answer. And I usually put this in my calculator first, and then take the square root of it. Then I don't have to worry about how long it is, and with all of those parentheses in there. And the answer is 189.9. All right, have fun.